Welcome to Feedback Mechanisms. This learning video explores how systems respond to their own output when it returns as input. This is known as feedback. Let's look at an example using the autonomic nervous system, which regulates various body functions without our conscious effort. For example, let's say you're running really fast. Your body temperature increases. This is the output of the system, a temperature change. What happens next? Well, you probably sweat. And sweating puts liquid on your body that evaporates. Evaporation is a cooling process. That is going to decrease your temperature, and that temperature change is the input. Notice that the output was a temperature increase, whereas the input was a temperature decrease. This is one possible type of feedback where the result is a return to where the system was before. A second possibility is that the output and input both increase the body temperature. Maybe in this case, you were running for hours in the desert and you were so dehydrated that there was no sweating. So let's look at these two different possibilities. The new input, as I mentioned, can do one of two things. It can return the system to normal, or it can push the system further from normal conditions. This first situation, where it returns the system to normal or stabilizes the system, is called a negative feedback mechanism. The second scenario, where it pushes the system further from what it was initially like, is called a positive feedback mechanism. So let's start out with negative feedback mechanisms. And keep in mind that negative does not mean bad. In fact, remember, negative means it stabilizes the system. It brings it back to where it originally was. So this is kind of tricky because negative doesn't mean bad and positive doesn't mean good. So let's look at this sweating example using arrows and loops. The temperature rises because you were running. It increased the sweating. That increased evaporation, and the temperature dropped. Oftentimes, we put a negative sign in the middle of a loop to indicate that it was a negative feedback. Let's look at another example related to climate. Let's say that the atmospheric temperature is rising. We're not going to say why it's rising, it's just rising. Well, one thing that can happen when the atmospheric temperature rises is that it increases chemical weathering. Remember, I mentioned chemical weathering in the last video when I talked about the hydrosphere and the geosphere interacting. Well, it turns out that chemical weathering uses carbon dioxide from the atmosphere, so the atmosphere gets involved as well. Now, carbon dioxide is a greenhouse gas that enhances global warming. So if chemical weathering increases, it actually takes carbon dioxide out of the atmosphere, which then decreases the greenhouse effect. As a result, temperature drops. So this is another example of a negative feedback mechanism. Okay, let's look at positive feedback. And again, this doesn't mean good. Positive feedback destabilizes the system. It pushes it towards a different direction. For example, a stampede of cow would be an example of positive feedback. So here's my cow, Bessie the cow. Now, it's hard to show you a stampede looking at a bunch of cows from the side. So we're going to look at a bunch of cows from the top. So in the next picture, I'm going to show you Bessie, but from the top. That's Bessie looking down on her in a field. And I'm going to show you Bessie with a bunch of other cows. Now what's going to happen, but in comes a rattlesnake. And that rattlesnake startles the nearest cow. And that cow jumps, moves, whatever it is that cows do when they're startled. And that startled cow startles two cows nearby. And those two cows startle four cows nearby. And so on, and so on, and so on. Oh, there goes Bessie. And so on, until we have a stampede. The system has now been pushed from a bunch of calm cows eating grass to a bunch of cows running around. So what do we have if we're going to use arrows and loops? We have a frightened cow that reacts. The very first act is one cow reacting. That frightens nearby cows. Those nearby cows react. They frighten nearby cows. Those cows react. They frighten nearby cows, etc., etc. And we put a positive sign in the middle. It's a positive feedback. We have pushed this system into a different direction. Let's use climate again as another example. And interestingly, we're going to start with the same initial prompt, atmospheric temperature rises. And this is one reason why it's so difficult to use climate models, because sometimes the same initial prompt produces a different result. So here I'm going to have the atmospheric temperature rise, and this is going to melt glaciers. Now, before I describe what happens next, I need to tell you about what happens when sunlight hits Earth's surface. When sunlight hits any surface, some of it is reflected back to space as if it hit a mirror, and some of it is absorbed by the surface that it hits, and it's turned into heat. Think about if you and your friend are out in the sunlight and one of you has a white t-shirt on and one of you has a black t-shirt on. Who is going to feel warmer in the sunlight? You probably answered the person with the black t-shirt, because black is a dark color and it absorbs the sunlight, which turns it into heat. White is a light color, it reflects the sunlight, and it is not turned into heat. So the same is true of things on Earth's surface. In this picture, you can see land and snow or ice. And it turns out land is darker than snow or ice. And so 70%, it's shown here, of the sunlight is absorbed, and only 10 to 20% is reflected back. And they're also showing water reflects about 10%. Over here, we have lighter colored snow or ice, and that reflects 85 to 90% of sunlight back up into the atmosphere so that it doesn't wind up heating the Earth. So what's going to happen if snow and ice melt and the underlying land is exposed? Well, the Earth is going to absorb more heat. So back to our positive feedback example, atmospheric temperature rises. This melts the glaciers. More land is exposed, more heat is absorbed, and that brings us right back to temperature rising even more. So throughout the semester, we're going to find a lot of examples of positive and negative feedback in the Earth. And when we do, I'll draw your attention back to this topic. Sometimes there are types of feedback that aren't even related to Earth science. Think about this. What kind of feedback happens to bands on stage through their microphones? You've probably noticed this. Maybe you've been at a concert and all of a sudden there's a huge screech of sound coming from the stage. Pause the video and think about this. Is that positive or negative feedback? Well, here's the answer. The sound goes into the microphone. That sound exits the amplifier much louder. That's how an amplifier works. But if that sound from the amplifier goes directly back into the microphone, then it's going to be amplified again, right? So that is positive feedback. When that happens, what does the person on the stage do? They grab that microphone and they turn it in a different direction, and the problem is solved. So, positive feedback. Coming up next, what Earth resources have you used today?